All right. Hi, folks. Welcome to our panel session. My name is Adeep Saikali. I'm a principal platform architect with VMware. And I like to call myself the code janitor, partly because a lot of customers always say, here's my code, please help me make it better.
Hi, I'm Asa, on point for everything developers need to build, migrate, and scale Java applications on Azure. I started Java in 1995 with JDK1, and I've been working with Java ever since. Azure Spring Cloud is a fully managed service for Spring Boot apps that lets you focus on building and running the apps that run your business without the hassle of managing infrastructure. Simply deploy your jars or code, and Azure Spring Cloud will automatically wire your apps with the Spring Service runtime. Once deployed, you can easily monitor application performance, fix errors, and rapidly improve performance. It's integrated into Azure's ecosystem, and it is enterprise ready. 2 weeks ago at Spring One conference, Microsoft and VMware announced the general availability of the service. Now, a little more details. The big rectangle is Azure Spring Cloud. It's built on Kubernetes. Your apps are running in one of the two dedicated Kubernetes clusters for each service. Your apps can interact with any Azure service or external service. Logs, metrics, and alerts are available through Azure Monitor. You can secure your apps using Azure Active Directory and automate using your favorite tools. Now, net, it's an easy way to get started, focus on your business objective, and everything else is taken care of for you in cloud.
And it's really important to know that this is a joint engineering effort between VMware and Microsoft. So you're going to get like an amazing experience using a Spring on top of Azure Spring Cloud.
Hi, Jonathan. You love simple architecture and incremental deployments. Tell us how you rapidly deploy to production.
Yeah, hi everyone. So yeah, in Group Finance IT, we're currently moving to Microsoft Azure, and we're following a strangler-based approach. So to avoid a big bang at the end of a many year project, we deliver small increments of functionality, and these gradually replace our existing systems. One day, or so the idea goes, we should go to bed, wake up, and be all in the public cloud. Azure Spring Cloud arrived at a good time. It fitted our strategy to concentrate on more abstracted infrastructure. The platform hosts our mini services. These are Spring Boot applications, and they allow the definition and execution of rules, management of data models, and validation of data. We chose Azure Spring Cloud to concentrate on writing apps and running them with minimum overhead. We didn't need to upskill in Kubernetes, and we don't need a heavy support organization to keep the platform up and running. We believe the team at Microsoft can scale the support far better than we could. The platform's simplicity, we simply give it a jar and have an application running, means we don't need a specialist DevOps engineer on call, but Microsoft definitely do. For us, this makes good economic sense. After some work to get the Spring Cloud Gateway wired up, we now have a landing zone. We can deploy other applications with very little overhead. It's more of the same. The architecture shows something that's very simple and fairly unremarkable, and we're happy with this simplicity. That's what we were aiming for.
Armando, you have been telling us no to Kubernetes, and you're on fast track, aggressive about deploying to production. Tell us how you advance to production.
Yes, thank you, Asir. Yes, I want our developers to focus on apps not Kubernetes. Hello, everyone. My name is Armando Guzman. I'm a principal software engineer at Rayleigh's. Rayleigh's is a Northern California and Northern Nevada grocery store. Rayleigh's has had an e-commerce site with in-store pickup for approximately 10 years. We currently use Azure as our primary cloud technology partner. Our architecture is a mix of cloud and distributed applications at each of our over 130 stores. Our digital presence in Azure starts with Azure API Manager, which connects to Azure Application Gateway to access web services in our VNet running on Azure Spring Cloud. Applications in Azure Spring Cloud connect to our Postgres database and our on-premise systems at each of our stores.
Peter, you have the best job title, Java Software Crafter. Tell us about your journey to Azure and how you are migrating apps to Azure Spring Cloud.
Yes. Hi, everybody. My name is Peter Verstraeten. I'm a Java software crafter working at a company called Continuum. And at the moment, I'm on assignment at Liantis, a leading integrated HR services provider on the Belgian market. And at Liantis, I'm the lead developer of a team that has to deliver a brand new application ready to be hosted at a cloud service provider. The application consists of several Spring Boot services and an Angular front end. Also note the connectivity to existing services and legacy systems on premise, both synchronous and asynchronous. Application currently is running on our on-premise Spring Cloud setup. However, major peaks in usage can be expected, so we require a platform that allows for dynamic scaling, which is a challenge for our current platform. As Azure is known and in use in our IT organization, we have decided to use the Azure Spring Cloud offering as the way to go for this application. Apart from Azure Spring Cloud, the most important other Azure services that we use are Azure SQL Server, an application gateway to direct the traffic to the backend services and keep them safe, and also Key Vault for storing secrets. And for the connectivity to our on-premise services and legacy systems, we depend on the VNet integration, which was recently added to the Azure Spring Cloud offering.
That's awesome, folks. You guys really you cover the gamut for the type of customers that are using Spring and Azure. Like the big thing that I hear from everybody is, I want to go to the cloud because I want to go faster. And so I'm really curious if you can tell us a bit about your workflow. What tools are you using and how often are you deploying to production? And maybe we'll start with Jonathan. Oh, I think
Jonathan is muted.
Oh, sorry. Yeah, our Java developers work with IntelliJ, and our Angular developers mainly use VS Code. We use Azure DevOps for everything, so all of our Git repositories, work items, and pipelines are hosted there. Our software is still built using Maven. In Azure DevOps, we use Azure pipelines. So unfortunately, potentially, we have lots of YAML. We separate continuous integration and deployment into separate pipelines. So all the tests, unit, integration, end-to-end are executed in the CI pipeline. The artifact it builds is deployed automatically to our development subscription. Currently, we manually push to higher environments, but this is all possible from within Azure DevOps, and we don't need a manual process outside of it. Automated testing to build understanding and pin the behavior of our software is probably the key part of our workflow. We practice test-first development. Basically, if you can't write a test for it, then don't write it at all. All our pull request approvers look for good tests with good assertions to support this strategy. And with Spring Boot, we have an excellent framework for doing all of this. We deploy all of our infrastructure via the Terraform task in Azure DevOps, and we were happy that the Azure Spring Cloud team provided a Terraform provider early on for this.
Yeah, thank you, Jonathan. I think Rayleigh's is very similar to you guys, but we do have some differences. So Rayleigh's uses Jira for agile planning, Terraform for infrastructure as code, IntelliJ as an IDE, Azure DevOps for source control and CI/CD. And just like you, our applications are built using Maven and stored in Azure artifacts. Our pipelines in Azure DevOps are a mixture of classic and YAML pipelines, but we are migrating all builds to be YAML-based. We are also investigating migrating from classic releases to YAML releases. Developers can deploy to our development environment from topic branches. Deployments to our staging environment are automatic and triggered by a pull request merging to master. Deployments to production are also done with pipelines, but are triggered by a product owner approving the release. Our infrastructure is deployed using Terraform, just like yours, and this is also in Azure DevOps, and we rely on the Azure providers as well. We have separate repos for Terraform modules we want to reuse and separate pipelines for each logical resource in Azure. For example, we have a pipeline each for API Manager, Application Gateway, and Azure Spring Cloud. Rayleigh is an Azure shop, and we continue to find that Azure meets all of our infrastructure and development needs.
At Liantis, we have a mature software factory in place that is used by more than 50 agile development teams with, well, the usual tools. IntelliJ for both Java and Angular development, Maven as a build tool, Bitbucket as our version control system. We have a Jenkins server in place with CI jobs and custom jobs to deploy to certain environments. Maintaining Jenkins jobs can be a nuisance, but with an in-house automation tool to generate and manage those jobs, that nuisance has been taken away. Also, SonarQube and Nexus are in place. An integration between Jira, Bitbucket, and Jenkins is set up, which smoothens the agile way of working within the teams. The release of a microservice to production is the responsibility of the entire agile team. And in fact, with the help of the Jenkins jobs provided, some of the teams deploy to production at the end of each iteration. This has also become common practice in our team. Extending our software factory to tap into the Azure ecosystem proved easy, as Azure provides the building blocks necessary to enhance our current Jenkins pipelines. To get familiar with those building blocks, one of our more ops-oriented colleagues has implemented infrastructure as code pipelines in Jenkins as a proof of concept.
Wow, it's like a microcosm here. I heard IntelliJ, Maven, Azure, DevOps, Bitbucket, SonarQube, Nexus, Jira, Azure Pipelines, Jenkins, and Terraform. Great that you represent the diversity of tools used by Java developers at large. Now, with so many things in play, when you're running apps and systems in cloud, how do you keep your end users happy and achieve service level objectives? How do you fix your app and system issues? Let's start with Peter.
Well, as said previously, having the possibility to dynamically scale up or down services when needed is a very important prerequisite for the application that we are currently developing. And of course, this is of utmost importance to keep our end users happy. Azure Spring Cloud covers this by providing the auto-scaling in-out feature. With the services already migrated, we've been experimenting successfully with this feature by performing several load tests using various scenarios. And when it comes to investigating issues, what is appealing is that everything you need is available through the Azure portal, such as distributed tracing with application map as a starting point, the possibility to drill down to transaction details, easy access to logs, or monitoring performance of services using the captured metrics. And from a developer's perspective, the integration of log streaming into the Azure Toolkit for IntelliJ is very helpful during functional testing of deployed services. And currently, we are further looking into the possibilities of alerts and custom dashboards.
Yeah, during financial closing periods, it's important we run a stable, accurate, and performant service for our business. One thing we do is expose Spring Boot actuator endpoints on all of our Spring Boot apps. These are automatically monitored, and any failures in these actuator calls raise tickets in our incident management system. The application map feature of Application Insights visualizes our distributed tracing, and it gives a mostly clear picture of how our applications are working with each other. We always want more insights. So I hope this Azure Spring Cloud team can soon implement the latest version of the Insights Java agent. This would give us telemetry on the JDBC calls too. Like Peter, we've recently started to integrate the platform's horizontal autoscaler. So as I said, like during financial periods, some of our services get particularly busy, and the ability of the platform to adjust the number of application instances based on metrics like heap size, number of requests, should enable us to meet peak demand. And with a platform feature like the autoscaler, this can be done without manual work or over provisioning of resources. And we also use the log stream feature of Azure Spring Cloud a lot, especially in development environments, to be able to tail or follow the application logs. And if we identify bugs, we'll always recreate them with an automated test case, fix it, then push to production. I guess ultimately we keep our end users happy by running a reliable and performant system, but we also need to ensure we gain and keep the business's trust by regularly deploying features which work as intended.
Yeah, I couldn't agree more, Jonathan. As part of the Unified Commerce team, me and my team are responsible for enrollment in our loyalty program, order processing, and personalized offers. All of these services must remain stable and online 24 hours a day. It's amazing how many customers shop for groceries in the middle of the night. We also have reoccurring events, product offers, $5 Mondays. These events drive customers to our site on a regular basis, resulting in predictable peaks. These known events are monitored closely, and we use Azure Monitor to send alerts whenever thresholds are exceeded. Currently, we ensure enough headroom is always available to handle our peaks, but we are investigating Azure Spring Cloud autoscaling and moving to Application Gateway 2.0, since that also supports autoscaling. Our developers are very happy with log stream and log aggregation in Azure Spring Cloud. These have helped debug and pinpoint problems very quickly. All defect fixes must be peer-reviewed using pull requests, deployed to our staging environment, and communicated before deploying to production. Azure Spring Cloud has allowed Rayleigh to quickly develop and deploy new apps while exceeding customer and developer expectations. The beauty of Azure Spring Cloud is that Rayleigh can take advantage of Kubernetes, but we do not need to learn how to manage a Kubernetes deployment.
Awesome. So I'm really glad you guys are talking about these things, because from my point of view, our customers, our business cares really about two things broadly. Number one is my business running? And you guys are just talking all about the great features that are available in Spring and Azure to keep you up and running. But the other thing that is always on everybody's mind is security. And I was wondering if you can tell us a little bit about how the security consideration factored into how you're using Azure Spring Cloud.
Yes, thank you, Adib. A major component of security involves protecting the network and having a zero trust network. Azure Spring Cloud supports deploying to private VNets, thus allowing Rayleigh to utilize Azure API Manager and Azure Application Gateway to protect our services from outside and inside the network. Azure Spring Cloud also natively supports Azure Key Vault. Rayleigh was able to move application secrets to Azure Key Vault, and after deploying Azure Key Vault for our Spring applications, we also migrated our Azure DevOps pipeline secrets to Azure Key Vault. Azure Spring Cloud also supports a Spring configuration server, allowing us to keep our configuration in Git repos and update configuration using pull requests and Azure pipelines. Azure Spring Cloud allows us to meet and improve our security posture while providing peace of mind that our services are secure.
Essential features and services like private VNet and application gateway were just mentioned by Armando. In addition to that, when it comes to identity and access management, Liantis has a solution in place based on one of the leading IAM providers, with a custom in-house Spring Boot starter integrating the solution with Spring Security is a smooth process, and we use this starter in the application we are currently developing. and it works perfectly. And the service is already deployed in Azure Spring Cloud. For now, our secrets are stored in configuration, and although they are protected by encryption, we decided to move our secrets to Azure Key Vault. This makes the management of secrets and keys much easier. At Liantis, we have the notion of company-wide and component-specific secrets, and we decided to store the different kind of secrets in separate Azure Key Vaults. And we were considering the development of a starter that allows a Spring Boot component to load secrets from multiple Key Vaults. However, recently, Microsoft released a new version of its own Key Vault, Spring Boot starter, and actually supports such an approach. And that was a pleasant surprise.
At Swiss Re, we're following the CSA CCM, which is quite a mouthful. It's the Cloud Security Alliance Cloud Controls Matrix, and choices we make have to be compatible with that. Our Spring Boot applications are checked for CVs, and we just can't deploy the software should vulnerabilities be present. We have automated smoke tests which run after a deployment. These check, amongst other things, that key aspects of our security policy have not been mutated by a new deployment. By delegating activities like network management and compute management to Microsoft, we lower our attack surface. The less moving parts we have to configure and maintain, the better. Microsoft also patch the Java versions, and they expose a fine-grained permission model, so we don't have too many people having too much unnecessary access. Managed identities are one of the best things in Microsoft Azure. So the system-assigned managed identity, which Azure Spring Cloud provides, is used a lot. Each application uses the managed identity to bootstrap access to Azure Key Vaults, access Microsoft Graph, and it authenticates to our static content, which is stored in Azure Storage. It's important that we minimize the exposure of our applications. So all of our backend services run on private IP addresses. All ingress comes through our Spring Cloud Gateway application, and that's shielded by Cloudflare, which has a web application firewall or a WAF, and this can stop, bad traffic before it reaches our Azure Spring Cloud instance.
So whenever I talk to customers, Java customers, they always tell me about the security is a challenge in the cloud, and zero trust model is pretty complicated. Clearly, here listening to you all, you have built systems in a way that they are secure and provide you with a peace of mind. And Peter, great that you like the new version of the Spring Boot Key Vault starter. We will look forward to hear more on that from you. Now, when you're in the cloud, there are so many options for you. Infrastructure, virtual machines, containers, platform as a services, and so on. What does cloud-native software development mean to you? And what advice do you have for Spring developers considering cloud? Let's start with Jonathan.
I think firstly for me, cloud native doesn't necessarily mean microservices. Our teams are building services that are decomposed to a level which makes sense to us. I don't want to distribute stuff without a good reason to distribute it. Cloud native ultimately has to provide tangible results which our business sponsors recognize. To help get these results, we want Azure to provide platforms for us. And of course, Azure Spring Cloud helps. It takes away implementation and management effort, which is not our core competency. We try and give our product teams autonomy and ownership. So self-service is a critical factor, perhaps a critical factor. We need to be able to make progress without waiting for service requests and long fulfillment chains. We continually aim to remove as much unnecessary friction as possible from the development process. We aren't magicians and we have no magic. By this, I mean everything we create and deploy must have a representation in Git. We strive for all of our services to expose clean and consistent APIs. And with the public cloud, of course, we never compromise on security. So we create a security baseline, we maintain it, and we try to improve it over time. And we automate as much as possible, and that includes the monitoring of our software. And we try to automate the response to that monitoring, the alerts as much as possible. In terms of advice for Spring devs, I think one piece of advice that has worked well for us, and this is applicable whether you target the cloud or not, is to get the basics right from day one. So from the first commit, do all the right things, everything in Git, automated tests, automated builds, and automated deployments, and then just take it from there.
Yep, I think that's very good advice, Jonathan. I think cloud native to me means creating applications that can take advantage of cloud services. Cloud native software development must facilitate rapid development, CI/CD, and auto scaling, just to name a few features. Cloud native software development allows developers to focus on the application logic, innovate, and quickly bring value to the business team, just like you said. Azure Spring Cloud supports all these features while eliminating the need to spend infrastructure and development resources deploying, configuring, and testing to ensure features are set up correctly. Adopting Azure Spring Cloud has made our developers more productive, allowed them to focus on the application and business logic without needing to worry about the underlying infrastructure, while adding in-demand technologies and skills to their resumes, making them very happy. Adopting Azure Spring Cloud shifts the management of Kubernetes, OS patches, and updates, just like you said, to the experts at Azure, making our development and business teams more productive. And I think that's the biggest advice I can give.
I heard Jonathan mention a self-service platform that teams can use to quickly get what they need during development. At Liantis, we started thinking in that same direction. The Spring Framework, together with Spring Boot and Spring Cloud, help to improve the microservice development process. Different kind of boilerplate aspects are taken care of, and the frameworks help developers to use architectural principles, design patterns, enterprise integration patterns, or distributed system patterns more easily. However, when going cloud native, a supporting platform or ecosystem with capabilities such as DevOps pipelines, centralized logging and monitoring, security, service discovery, centralized configuration, scaling, and so on, is an absolute must. First of all, to streamline the development process, and also to act as the hosting platform for the developed microservices. By adding Azure and Azure Spring Cloud to that Spring trio, you remove a major burden from your IT organization in setting up and maintaining such a supporting ecosystem. And once in place, it allows our agile teams to focus much more on producing business value and functionality, and doing so with less or even no worries at all.
Thank you. Thank you for sharing those valuable tips. To summarize, the first is day one, do all the right things. Second, use cloud native frameworks trio, Spring, Spring Boot, and Spring Cloud for enhanced productivity. And third, take advantage of cloud services, particularly platform services like Azure Spring Cloud, without worrying about the underlying infrastructure. So on behalf of Adib and myself, thank you, Jonathan, Armando, and Peter for joining us and sharing your valuable experiences, insights, and wisdom. It's very inspiring to hear your stories to production and how you have navigated through tooling, automation, security, service level objectives, and leverage cloud native solutions. Now, everybody who's watching on YouTube or Learn TV, thank you for joining us today. Everyone can build cloud native solutions today and advance them to production. We love to hear how you are building impactful solutions using Azure Spring Cloud. You can get started today. Quick start is a good start. You can also use a self-paced workshop. We have migration guides for you, migration from Spring Boot, Spring Cloud, Tomcat, and we'll continue to publish more migration guides. Let us know how you are building impactful solutions. Thank you again for joining us.
Thanks, everyone.